All right, so this is going to be a video about simplifying and verifying trig identities, and this is basically the learning objectives that we're going to be doing. Verify the fundamental trigonometric identities, and then simplify trigonometric expressions using algebra and the identities. The main identity that we're going to be using, it's called the Pythagorean identity, is this thing right here up at the top. I'm going to highlight it here, this part right here. Super important that you know this. Make sure you write it down. Basically, it's using the fact that the unit circle can form all those triangles on that circle, and they all have a radius of 1. So the x squared plus y squared equals the radius squared. That actually forms all of the triangles on the unit circle, and that's why it's called the unit circle, because the radius is 1 unit. The base of unit is 1, like uno, if you think about it in Spanish. So that's why it's called the unit circle. You don't really need to understand that necessarily for the class, but you do have to know how to apply it, and you have to know that sine squared plus cosine squared equals 1. We'll be going over this in more detail in class, but make sure you actually know that identity, because we're going to be using it not so much in this example problem number 1, but we are going to be using it in example problem number 2 and number 3 down here. All right, so this is basically the gist of verifying trig identities, what I'm about to show you here, and the easiest way to show this is just using examples, so that's what I'm going to be doing. So it says verify that tan theta times cosine theta is equal to sine theta. So we need to verify this, and we need to use trig identities in order to verify this. Well, one of the easiest ways to do that is understanding that tan theta is really just sine over cosine, sine theta over cosine theta. So I'm actually going to rewrite this tan theta right here as sine theta divided by cosine theta. Okay. I'm still going to multiply by that cosine theta right here. That doesn't just go away. Times cosine theta. And then this needs to be equal to sine theta. To verify this, what I'm going to be looking for you to do on the assessments, on the quizzes, tests, that kind of a thing, is showing that this is actually true by canceling things out. So the cosine theta divided by cosine theta is 1, and you end up with sine theta is equal to sine theta. This means that you verified that the original, the tan theta cosine theta, so the original equation, this whole part right here, has been verified, because if you simplify it all the way down, they end up being equal on both sides, and that's how you know you did it right. Okay, if you get sine theta equals sine theta, you know that you did it right. Note that I only really messed with one side. I messed with the left side, the tan theta times cosine theta. So ideally when you're doing these, you are always going to want to just mess with one side. The other side should just be left alone and just kind of be there to be proved. So I simplified the left side to be sine theta. It's equal to sine theta. It checks out. It is officially verified. That is the answer. So number 2 is more complicated than number 1. You still have to understand how to do number 1, because you'll see simple problems like that, but a lot of them are more complicated like this one. So let's break this down. First thing we're going to do is we're going to simplify this left side here. Okay, what I just highlighted in green. Secant squared divided by secant squared is going to be 1, and then minus 1 over secant squared. So I'm going to write minus 1 over secant squared theta is equal to sine squared theta. So essentially what I did is I divided this part right here by the secant squared. That's how you get the 1. And then I divided 1 by the secant squared, and that's how I got this part here. So basically just distributed out that division part of that expression on the left. Okay, now from here, 1 minus this 1 over secant squared, you have to know that 1 over secant theta is equal to cosine theta. But since it's squared, it's 1 over cosine squared. This was covered in a previous class, but you should note that 1 over cosine is equal to secant. Okay, 1 over cosine theta is equal to secant theta. All right, equals sine squared theta. All right, from here, we're going to use our Pythagorean identity. So if you notice, it says 1 minus cosine squared. Whenever you see a 1 and a cosine squared or 1 and a sine squared, chances are you're going to have to use this thing up here. If I subtract cosine squared on both sides, you will get sine squared theta is equal to 1 minus cosine squared theta. So I just subtracted cosine squared theta on both sides. So that means that this part is equal to the sine squared theta, which means this part right here is equal to the sine squared theta. So that's what I'm going to do, is write that down. 1 minus cosine squared theta is equal to sine squared theta, which is equal to, go figure, sine squared theta. We just proved it. So that means this is officially verified, and I went through the entire process of simplifying it all out in order to get the answer. So that's basically how you do that one. All right, number 3. Okay, this one's a little bit more complicated again. But what's cool about this one is it starts off with that 1 minus cosine squared x. Okay, we know already from the last problem that this part right here is going to be equal to sine squared x, based on that Pythagorean identity from the very top. Okay, this one right here, it says 1 plus cotan squared. Well, cotan is cosine of x divided by sine of x. But since it's cotan squared, I have to square the top, square the bottom. This is equal to 1. So I basically did this part right here. And you will notice me do this a lot when we go over examples in class, is whenever you see something that does not have sines and cosines in it, you are going to want to translate that into sines and cosines. So that cotan, I turned it into cosines and sines. Okay, another thing I did up here with a tangent, I turned it into sine over cosine. Okay, you're going to want to do that every time. It causes things to simplify a lot more. So make sure you do that. That is one of the steps that I highly recommend you do. Now from here, we're going to simplify this further by distributing. So this part right here, I'm going to distribute it to the 1, and then I'm going to distribute it over here to this cosine squared over sine squared. And you're going to be left with sine squared of x plus sine squared of x times cosine squared of x divided by sine squared of x is equal to 1. So I just distributed that sine squared of x. And what's great about this is it simplifies like so. And then you end up with sine squared plus cosine squared equals 1. Well, we already know that sine squared plus cosine squared is equal to 1 based on that Pythagorean identity. So that this left side just becomes 1, and then the right side is still 1 as well. 1 equals 1. That checks it and verifies that the identity is correct. So if you notice, all 3 of these examples all have the steps that you break down, completely simplified, and then you end up with being equal to that right side. Generally speaking, the left side is what you have to simplify, and the right side just kind of stays the same. It's not always like that, but most of the time it is, just so you're aware. So that's basically simplifying and verifying trig identities. If you have any questions about anything in this video, let me know.